Assalamu alaikum, everyone. So today's class is about the air pollution concentration models. We use these models to try to estimate what is the concentration of pollutant coming out of a stack or coming inside an area, and how it is distributed within this area. So it's mathematical models that we can use to estimate concentrations everywhere. The main idea that we need really to understand or to know, to build on in this chapter is the mass balance. So we have covered this in the CIVL 270 class. I would ask every one of you, please, to go back and check the CIVL 270 mass balance classes. I will put a link for the CIVL 270 videos in the comment section. So please go and check it out about the mass balance. It's very important, and you really need to go through it, solve some examples also to make sure that you understand it very well. So why do we use these models? First, the models are mathematical tools used to predict the concentration of pollutants in the ambient air resulting from various emission sources. Could be one, could be more. But let's say I have a hospital next to the industrial area. I want to understand what would be the concentration of any pollutant at this hospital at any time. So I need mathematical tools that can help me calculate this or estimate this concentration. And therefore, we developed several models. We will only talk about two of them today in order to calculate or estimate this concentration. So the purpose of these models are to understand how pollutants disperse, transform, and settle in the environment, which is crucial for effective air quality management. So where do we use that? We use that in three main categories: regulatory compliance, environmental impact assessment, and public health protection. Regulatory compliance means that to make sure that you follow the rules, regulation, thresholds set by your agency. Environmental impact assessment is a whole study that looks for what are the environmental impacts of new constructions, new projects. And part of it is air modeling. And finally, public health, as we're talking about the example of the hospital, where we want to make sure that some sensitive places are have better air quality that will not affect public health. For example, schools, hospitals, and so on, nursing homes. So with regulatory compliance, we need to show, for example, that we are below the NAAQS. We all know what the NAAQS is. So in the United States, air pollution laws are based on maintaining pollutant concentration below certain thresholds to protect public health and environment. So we use the models to plan and execute air pollution control programs to ensure compliance with these standards. For example, we have a new factory that is want to start building in Musaffah in Abu Dhabi. So we look at what are the values in the monitoring stations around Musaffah. We see maybe the ozone has some exceedances. So how will the new NOx and the new CO and the new VOC that is emitted by this factory will affect my ozone concentration? How do I know that? I start to model, knowing what is my background and what I am adding, and how much will this be now at the new at the same location of this monitoring station. Depending on how much exceedances I will get is how I can give permit to construct this factory to start with, or maybe change the design of the factory, change the technology that's used in this factory, and so on. Number two is for environmental impact assessment. We use models to predict the environmental impacts of new projects or changes in existing projects, helping to mitigate adverse effects. And environmental impact assessment are done for large projects before they even start their planning. And they provide the scientific basis for making informed decisions about emission controls and regulatory measures. Finally, for the public health protection. By predicting pollutant concentration, models can see how much exposure of pollutants to harmful pollutants there is. And I want to take you back again to the CIVL 270 in the class of risk. When in the risk, we were talking about that there is some exposure and there is the dose response. And the exposure part of it, the air part, is done by these models. Health risk reduction, they support strategies to reduce health risks associated with air pollution, such as respiratory and cardiovascular disease. So the next video, we will be introducing the fixed box model. Thank you for listening.